In this video, I am going to discuss about resistance welding process. Short form is RW process. Resistance welding process is a group of welding process in which heat required for welding is obtained from the resistance offered by the work to the flow of electric current in a circuit, and the joint is affected by the application of pressure. In a resistance welding process, the heat required for welding is obtained from resistance offered by the work to the flow of electric current. So during resistance welding process, current is flowing through the workpiece to be jointed. The heat is produced by the resistance offered by the workpiece to the flow of electricity. And after the material is heated to plastic state, correct amount of pressure is applied and a metallurgical joint is created between the parts. So this is the working principle of a resistance welding process. So in a resistance welding process, heat required for welding process is obtained from the resistance offered by the work to the flow of electric current in a circuit, and the joint is created by the application of pressure. There are different types of resistance welding process. The principle will be same for all the resistance welding process. There are 5 classification of resistance welding process. First one, spot welding process. Second one, seam welding process. Third one, projection welding process. Fourth one, flash butt welding process. Fifth one, upset welding process. So we can discuss one by one. First one, spot welding process. See, in a spot welding process, material to be joined are placed between electrodes. See, in a spot welding process, material to be joined is placed between 2 electrodes. Pressure is applied after a quick shot of electricity is sent from one electrode through the job to the other electrodes. See, in spot welding process, initially the 2 pieces to be joined are placed between 2 electrodes, and pressure is applied after a quick shot of electricity is sent from one electrode through the job to the other electrode. There are 3 steps in a spot welding process. This is the figure of spot welding process. Spot welding process consists 2 electrodes. Copper alloy electrodes are commonly using, which have a water cooling system, internally circulating water cooling system in order to cool the electrodes. These are the workpiece to be jointed. Commonly lap joint will be formed through spot welding process. So initially the workpiece to be joined are placed between 2 electrodes. Okay. There are 3 steps in a spot welding process. The first step is the parts to be joined are clamped between the electrodes. Parts to be joined are clamped between the electrodes. In the second step, a high current is allowed to pass through the clamped members and is raised to the welding temperature. In the second step, high current is passed through the clamped members and is raised to welding temperature. The third step is current being cut off and high pressure being applied to the joint, and the joint is completed. So there are 3 steps in any spot welding process. First step is the part to be joined are clamped between the 2 electrodes. Second step, current is passing through the parts and the temperature is raised to welding temperature. Third step, the current is cut off and a high pressure being applied and the metals are jointed. So this is the working principle of a spot welding process. See, these spot welding process are commonly used for welding materials like aluminum, copper, stainless steel, and galvanized metals. So these are the application of spot welding process which are commonly used for welding aluminum, copper, stainless steel, and galvanized metals. Second one is resistance seam welding process. It is also known as roller spot welding process. Roller spot welding process. Okay. See, in a seam welding process, roller type electrodes are used. See, this is the figure of seam welding process which uses roller type electrodes. As the electrode revolves, the current is automatically turned on and off at interval corresponding to the speed at which the parts are set to move. With a proper control, it is possible to obtain airtight seams suitable for container, water heater, and fuel tank. See, in a seam welding process, roller type electrodes are commonly used, which is also used for producing overlap joints. See, during the seam welding process, the roller type electrodes are rotating or revolving, and the current is automatically turned on and off at intervals corresponding to the speed at which the parts are set to move. So the rollers are rotating continuously. The part is feeding inside the gap between the rollers at a rate correspond the speed of the rollers, and the current will be automatically switching on and off during seam welding process, and airtight joint will be produced. See, this seam welding process are commonly used for producing airtight joints in containers, water heaters, and fuel tank, etc. And this seam welding process, it is also known as roller type welding process because the electrodes are rotating during the welding process, and roller type electrodes are used. And these roller type electrodes are cooling by spraying waters or internally circulating water during the seam welding process. And third one is projection welding process. This type of welding is used for attaching fasteners to structural members. This is a very important point. The main application of projection welding process is attaching fasteners to structural member. See, the point where welding is to be done has a projection, which have been formed by embossing, stamping, or machining operation. What's the purpose of the projection is? The projection serve to concentrate the welding heat at this area and facilitate fusion without necessity of employing large current. See, this is the figure of projection welding process. In a projection welding process, the point where welding is to be done has a projection. The point where welding is to be done has a projection. It has been made by embossing, stamping, or machining operation. And what is the purpose of this projection? The projection serves to concentrate the welding heat at this area. Projection serves to concentrate the welding heat at this area and facilitate fusion without necessity of employing large current. So large electric current cannot be needed for projection welding process. See, brass and copper do not tend themselves to this method because the projection usually collapses under pressure. So during this projection welding, after the parts to be joined are placed, overlap each other, a high pressure is applied through flat copper dies. So these are flat copper dies. One will be remain stationary, other will be moving up and down direction. So during this process, a pressure will be applying over the material. So brass and copper, there is a chance that it will collapse. That's why brass and copper are do not weld by this projection welding method. And projection welding method are commonly used for welding fasteners to the structural members. Okay. Next one is flash butt welding. See, in a flash butt welding process, two pieces of metals to be joined are firmly held in a clamp which conduct current to the work. Two ends of metal pieces are moved and away from each other until an arc is established. The flashing action across the gap melts the metal, and as the two ends melt and forced together, fusion takes place. The current is cut off, and just before the heavy pressure is applied through the movable clamp. See, in a flash butt welding process, this is a schematic diagram of a flash butt welding process. Flash butt welding process are commonly used for welding round rods above 250 mm diameter, above 250 mm square cross sectional area. See, what is the application of the flash butt welding is, which is used for joining of round rods which have above 250 mm square cross sectional area. One round rod is clamped to the stationary clamp and other one is clamped to the movable clamp. Initially, the movable clamp is moving towards and away from the stationary clamp. See, this will be moving towards and away from the stationary clamp in order to make a flash here. And that flash will melt the end of the metal to be jointed and move to a plastic state. And after that, the current is cut off and the movable clamp will be suddenly moving towards the stationary workpiece, and a high pressure will be applied and a metallurgical bond will be created. So this is known as flash butt welding process. See, what is the main disadvantage of flash butt welding process is, after the welding process, a projection will be created here. A flash or a projection will be created here. A bulged portion will be created here at the point of weld. It should be removed by grinding or other machining operation. And the main application of flash butt welding process is, which is used for joining round bar above 250 mm square cross sectional area. The last one is butt or upset welding. See, in butt welding, the metals to be welded are in contact under pressure. An electric current is passed through them and edges are softened and fused together. See, in a butt welding process, this is a figure of butt welding process. Butt welding process actually does not consist a bulged portion after welding operation. See, in butt welding process, the round rods that are to be joined initially contacting with each other. In previous one, it will not contacting each other initially. It will be moving towards and away from each other in order to create a flash. But in this process, it will be remain contacted each other and current is passing. When the current is passing, due to friction, the heat will be producing here, and this welding area will be get heated and a metallurgical bond will be created. See, this process differs from flash butt welding in that constant pressure is applied during the heating process, which eliminates flashing. Heat generated at the point of contact resulting from resistance. See, in this process, flash butt welding process, what is the difference between flash butt or upset welding process or flash butt welding process? എന്താണ് ബട്ട് ഓർ അപ്സെറ്റ് വെൽഡിങ്ങും ഫ്ലാഷ് ബട്ട് വെൽഡിംഗ് പ്രോസസ്സും തമ്മിലുള്ള ഡിഫറൻസ് എന്താണ്? സി, ബട്ട് ഓർ അപ്സെറ്റ് വെൽഡിംഗ് പ്രോസസ്സിൽ രണ്ട് റൗണ്ട് പീസ് കോണ്ടാക്ട് ചെയ്ത് വെച്ചതിന് ശേഷമാണ് എന്ത് ചെയ്യുന്നത്, കറണ്ട് പാസ് ചെയ്ത് പോകും. ഫ്ലാഷ് ബട്ട് വെൽഡിങ്ങിൽ രണ്ട് റൗണ്ട് പീസുകളിലാണെങ്കിൽ മൂവബിൾ പീസ് ജസ്റ്റ് മൂവ് ചെയ്യും, ഫോർവേഡും ബാക്ക്വേഡും മൂവ് ചെയ്ത് ഫ്ലാഷ് ക്രിയേറ്റ് ചെയ്യും. ആ ഫ്ലാഷ് കൊണ്ടാണ് എഡ്ജസ് എന്ത് ചെയ്യുന്നത് സോഫ്റ്റൻ ചെയ്തു. പക്ഷേ ബട്ട് ഓർ അപ്സെറ്റ് വെൽഡിങ്ങിൽ രണ്ട് പീസും കോണ്ടാക്ട് ചെയ്ത് വെച്ചതിന് ശേഷമാണ് കറണ്ട് കടന്നു പോകുന്നത്. ദെൻ ആ ഒരു ഇൻ്റർഫേസിൽ എന്ത് ചെയ്യും, റെസിസ്റ്റൻസ് കൊണ്ട് ഹീറ്റ് ജനറേറ്റ് ചെയ്തിട്ട് ഈ എഡ്ജസ് സോഫ്റ്റ് ആവും, ദെൻ ക്രിയേറ്റിംഗ് എ മെറ്റലർജിക്കൽ ബോണ്ട്. സോ ദാറ്റ്സ് ദ ഡിഫറൻസ് ബിറ്റ്വീൻ ദി ബട്ട് ഓർ അപ്സെറ്റ് വെൽഡിംഗ് ആൻഡ് ഫ്ലാഷ് ബട്ട് വെൽഡിംഗ്. See, this butt or upset welding is limited to parts with a cross section area of not more than 200 to 250 mm square. See, 200 to 250 mm square cross section area ഉള്ള up to that value area ഉള്ള round rodsനെ join ചെയ്യാനാണ് butt or upset welding യൂസ് ചെയ്യുന്നത്. Flash butt welding means it is used for joining round rod cross section area above 250 mm square. Okay. So what is the advantages of resistance welding? Widely used for joining sheet metal. A speedy process, no distortion. Less skilled operators can do this work. No problem of edge preparation. So these are the advantages of the resistance welding process. So what are the application of resistance welding process? Spot and seam and projection welding is widely used in the production of car, tractor, farmer, machine, rail coaches, where thin sheet are to be jointed. See, the main application of spot welding process is in automobile industry, where thin sheet are to be jointed. Large sections like square, rectangular, cylindrical rod with regular and irregular ends faces are welded without edge preparation by flash butt or butt welding process. So these are the application of the resistance welding process. You have to study the application. That's very important point. So in this video I have discussed about the resistance welding process. What's the principle of resistance welding process? There are 5 classification of resistance welding process and advantages and application of resistance welding process. Thank you.